This is part 1 of the gas laws. Remember that the gas laws are based on the assumptions of the kinetic theory of gases. The ideal gas law states that pressure times volume is equal to the number of moles times the universal gas constant times temperature. PV equals nRT. From this equation we can extract the eponymous gas laws. If we set number of moles, universal gas constant, and temperature as constants, then we can see Boyle's law, which is pressure times volume is equal to a constant. Therefore, pressure is equal to a constant divided by volume, or pressure is inversely proportional to volume. This will derive a rectangular hyperbola graph where for every incremental increase in volume, there's a proportional decrease in pressure. This is different to an exponential. Boyle's law can be restated as P1V1 equals P2V2 for a changing system, and this can find clinical application when trying to work out the volume of gas that will be liberated from a pressurized cylinder of P1 and known volume V1 at a known pressure P2, which is 1 atmosphere, for example. There, V2 is equal to P1V1 divided by P2. This will tell us the amount of oxygen that we can derive from our cylinder, because oxygen is stored as a gas under pressure. If we recapitulate the gas law, PV equals nRT, we can then set V as a subject volume equals nRT divided by P. If we then set N, R and P as constants, so for a fixed mass at constant pressure, we can extract Charles's law, where volume is equal to a constant times temperature. Therefore, volume is directly proportional to temperature, giving us a graph of V versus T of a straight line. The gradient of this line is delta V over delta T, and that's equal to a constant, which is nR over P. Charles's law can also be restated as V1 divided by T1 is equal to V2 divided by T2. So going back to the ideal gas law, PV equals nRT. If we set pressure as a subject, we get pressure is equal to nRT over V. So for a fixed mass at constant volume, we can extract Guy Lussac's law, which shows that pressure is equal to a constant times temperature. And pressure is therefore directly proportional to temperature. So the graph of P versus T gives us a straight line, and the gradient of that is delta P over delta T, which is a constant, which is equal to nR over V. Finally, Guy Lussac's law can be restated as P1 divided by T1 is equal to P2 divided by T2.